This module is called Organic Chemistry, and it's the study of substances that contain carbon atoms. Hydrocarbons are a really important part of organic chemistry as their properties make them useful in modern life. Remember, a hydrocarbon is any molecule that is formed from carbon and hydrogen atoms only, and the simplest type of hydrocarbons are called alkanes. Alkanes are made up of chains of carbon atoms surrounded by hydrogen atoms. Carbon atoms form 4 bonds and hydrogen atoms form only 1 bond. The first 4 alkanes are methane, ethane, propane, and butane. The smallest one of these, with the fewest carbons, is methane. Crude oil is a finite resource. This means that it's being used faster than it can be made. Once it is used up, we'll not be able to replace it. It is described as a fossil fuel because it was formed from the remains of plants and animals, mainly plankton, that died millions of years ago and were buried in mud. Over millions of years, with high temperatures and pressure, the remains turned into crude oil, which can be drilled up from rocks where it is found. Crude oil is separated by a method called fractional distillation. Now, draw the structure of butane has 4 carbons. So I told you carbons form 4 bonds and hydrogens form 1 bond. So butane has 4 carbons and 10 hydrogens. In lower school, you learned about a simple process of distillation, which we use to separate 2 liquids. Crude oil is a mixture of many different compounds, so the process has to be more complex. Most of the compounds in crude oil are hydrocarbon molecules, and the majority of them are alkanes. Crude oil can be split into separate groups of hydrocarbons by a process called fractional distillation. The crude oil is pumped into a piece of equipment known as a fractionating column, which works continuously. This fractionating column has a temperature gradient running through it. It's hottest at the bottom and coldest at the top. The crude oil is first heated so that it evaporates, turns into a gas, and then it is piped in at the bottom of the column. The gas rises up the column and gradually cools. Different compounds in the mixture have different boiling points, so they condense, turn back into a liquid at different temperatures. This means they condense at different levels in the fractionating column. Hydrocarbons with similar numbers of carbon atoms have similar boiling points, so they condense at similar levels in the column. Which property of liquids allow them to be separated by distillation? So this is their boiling point. So we passed through then a series of slides asking you to draw and label a fractionating column so that you would have all the information that you needed in one place for this lesson. The tower is cooler at the top than it is at the bottom. So you were asked to sort these temperatures out, and it would go from coolest temperature at the top to the hottest temperature at the bottom. Okay, you were then asked to match up the different names of the fractions with the boiling point. So you could have added these names onto your diagram. And then the uses of each fraction. And you were given a summary diagram so that you could mark and make any corrections. So if you missed this lesson, you should pause the video now and you should copy this diagram out so you have this information ready. Okay. So, in summary, as crude oil is heated, some of the fractions evaporate and rise up the column. As the fractions rise, they cool down, meaning they condense. The fractions towards the bottom of the column have higher boiling points than those at the top. Then there was 2 more summary boxes to add to your diagram. So if you missed this lesson, pause this video and add those diagrams. As chains get longer, the boiling point increases. The larger the molecules, the stronger the forces of attraction between them. Earlier I said chains with similar lengths had similar boiling points and would come out in the same fractions. This question may have been a little more confusing because the last fraction fell off the top line on this question. There are 2 molecules with 2 carbons, which would be in the same fraction. C7 and C11 are quite close and would likely be in a similar fraction. C20, 20 carbons, is possibly a further fraction on its own. When you labelled your diagram, you should have placed petrol above diesel. Petrol boils at a lower temperature, so it must have a smaller chain length. Finally, an application question, which stumped a few of you. The temperature that a gas condenses at is the same as the temperature it boils at. So hydrocarbon X has a lower condensing and therefore boiling point. The lower the boiling point, the shorter the chain. Thanks to those of you that are still working hard. You are awesome, and I will see you in the next lesson.